Hi there, and thanks for joining me for this special episode of Mr. Ed Codes. It's been a while since I've done one of these, and I'm doing this now because P5.js is doing a fundraiser where they're trying to raise money for their platform. It's a free resource to people who want to learn how to code as a career, or if they would just want to do it as a hobby like me. I'm almost 50 years old, and I was fortunate enough to learn how to program when I was in middle school. Not a lot of my peers were even interested in it because it was kind of new at the time. But I was interested in it, and I learned how to code in all kinds of different languages. So learning P5.js was just a progression of this long road of learning how to code in different languages. I love P5.js because it's like the best of everything. So much of it is all the hard work basically is done for you, and you just have to put these pieces together. And they have a lot of examples on the P5.js website. One of those examples, which I'm showing here, is called flocking. So what I wanted to do with this is show that you can make a few modifications to these examples and create some cool visualizations. In this example, it's visualizing the movements of objects as they see where one another are, and they get close to one another, and then they fly in kind of the same direction. And all of this is the average of the group. So it's a clever way of getting this behavior to be illustrated, this flocking behavior. But I wanted to visualize it in a different way. I want to see when they're really close together, I want to see a unique kind of state. And then when they get further away, I want to see that state change. So I thought about drawing a line between them. When they get close, you draw a thick line, and then as they get further away, you fade that line out and it gets thinner. So that's what I'm going to do with this, and you'd be surprised how few changes you have to make to this program to get that to happen. So the first thing we're going to do is kind of look over what's happening with the program itself. We have an array, and we have a class, and in that class there's a bunch of the class functions here. There's seek target, render. There's a here, if it goes off the edge, it moves around. It's a wraparound right there. There's a subfunction to handle how the bird's separations operate, how their alignments operate, and how their cohesions operate. And in those subfunctions, we'll see there's a variable here, and then there's just this hard value. We're going to change that hard value to a variable because we're going to use that. And that's neighbor distance, so I'm just going to use ND because I'm old school. Neighbor's distance, right? So that occurs again up here in alignment. So let's change that to the variable that I'm just making up right now. And then there's another value here, desired separation. Since I'm going to be visualizing this as a relationship between the proximity of these objects to one another, that's related to their separation. So I think what I'm going to do is going to happen within this subfunction. And their desired separation, this 25, is half of the neighbor distance variables. So what I'm going to do is just create a ratio here. So I'm going to use that variable ND, and I'm going to multiply it times 0.5, which is basically taking half of it, just like it was there. And if you multiply times a fraction, it avoids the division by zero problem. So if you're wanting to divide something by half, always multiply it times 0.5, and then you never have to worry about it. Just a little tip there. So once I've done that, I have to declare this variable because P5.js doesn't know what ND is. Well, now it does. It's going to be 50 just like it was before. So if I run this program again, the output hasn't changed in any appreciable way. It's still performing the same way that it did before. I now, though, can change this one variable, and it's going to change the characteristics of this behavior. You're going to see the separation is, there's less separation, so they're clumping together more closely when I reduce that neighbor's distance. Of course, that makes sense, doesn't it? Let's increase it. And here you can see they They have some really good separation here. So basically this is going to scale whatever visualization I'm creating. Those distances are scalable by this neighbor's distance variable, so I can make the objects in the end bigger or smaller just by adjusting this variable. But I'm going to put it back to the original for now. I'm going to leave the screen the same size for now, but I did want to change the background to something a little bit more high contrast. So I'm going to use black at full intensity, just for now, full intensity. But I'm going to change that later to create a different effect. So now, because we don't want to see the birds part, it's just eating up processing speed. So I really don't need this sub function. So I'm going to comment that out. Basically that is just, it's not going to jump to this part here, this render part. And if I run the program, you can see that now we don't see the birds floating around. And there's no error, the program's running fine. So let's go down to that separation class function, and we want to look at it. So basically it's taking its current bird and it's comparing its current bird's position to the position of all the other birds, and it's doing that with this for loop here. And the array that holds all the other birds' position is Boyd's I to be exact, and it's this dot position is the current position. We can see that expressed here because they're testing the distance, and that's the variable that we want to use, is the distance variable. So it's doing the hard work for us here. It's figuring out the distance between the current position and the other birds. So we can use that variable, and that's exactly what we're going to do. But where are we going to use it at? Well, whenever they do get close, there's a particular operations are performed, and that's right here with these difference normalizations and steering. So we're going to jump into that condition here. And that condition is if they're on top of one another, or if they're within a certain range, that desired separation variable, then it's going to perform what's inside this condition. So that's where we're going to use this distance variable. So what I want to change in how the visualization is going to occur is going to affect the alpha of the color. So how faded it looks, if it's intense or faded. And it's also going to affect the thickness of the stroke, whether it's really thick stroke or a narrow stroke. So I'm going to start with the alpha part of the color, and I'm going to create a variable called stroke alpha SA, because I'm old school, and I'm going to use the map function. If you don't know what the map function is, find out, because it's awesome. It's so powerful and it's easy to use. What map function does, it's something that I would use to have to code into a program, and it was a bit of a pain, so I didn't want to use it a lot. But this makes it so easy, you want to use it all the time. So I am. So we're going to map, it's basically taking a range of one variable and plotting it in relationship to a range of another set of variables. So the first range of variables is the distance, and it's running in this condition from 0 to the desired separation. And I want to map that to the alpha, which is going to be its most intense or its least intense. And I'm not going to shut it off completely like 0. I'm going to have a little bit there. And the next variable I want to do is the stroke weight, SW. I'm going to map that to this stroke alpha variable. So if I change that, it's always going to be in relationship to the alpha and never in relationship to the desired separation, because then it lets you do some other things to it. So that's in a range from 255 to 25, and I want to map that to a stroke width of 8 if it's really close, and then as it gets away, it pulls away and gets down really thin to 1. So now that I have those, I can start putting them in. So my stroke, I want it to be maybe a light blue color. And I'm going to put that stroke alpha in there. Stroke weight. Now I'm ready to draw the line, and I need the variables that I'm going to draw the line from. And like I said before, it's this dot position and Boyd's array A, or array I. position. So this dot position, and I need an x variable there, so I'm going to do dot x. The reason why I'm going to do dot x and dot y is because that's a part of this dot position. It's part of its vector, so I'm allowed. But if if x and y was, you just can't make up a variable and put dot at the end of something. It has to be associated. Voids, be sure to put that s on there. The array of that and its position x, and then we're going to redo that with y. Now if I spelled everything wrong and I put periods instead of commas, everything should be right. Let's get rid of that extra bracket. Well, now let's see, cross your fingers, let's see if I remembered everything that you're supposed to do to this. And there we go. Now instead of seeing the birds themselves, we're seeing how they're relating to one another, how close they are or far apart to their neighbors. And it's generating this stroke, and it's also generating these cells, which represent the space between three birds or more. So instead of seeing the birds, we're seeing the relationship of the space between them. It's a different way to visualize the flocking behavior, and it creates an entirely different kind of effect. From an artistic point of view, it's like a different color of paint. It's the same kind of thing, but it's just a different color, different flavor of it. So it's very, I don't know, sterile right now. It's not, I want it to look ghosty. So one of the things that I can do is I want to affect the alpha here. I want it to be about half its possible intensity. That will be its maximum intensity. It will be at about half. And because I'm doing that, I want to take the background down. How vigorously is it clearing the background? I want it to clear it very lightly, a little bit at a time. Wipe away a little bit at a time. So we're going to take the alpha of the background down to 25. And then let's see what this does. So that's going to give it a little bit more of a ghosty, kind of smoky effect. And very small changes. Now you can see the cells are small in size. Remember I was talking about adjusting the distance can be our scalable factor. That's what we use to scale. And that's because the visualization is showing the relationship of distance. So if I scale up the neighbor's distance, I'm going to scale up the visualization. So let's take that up a little bit and see what happens. You can see there the cells are a little bit larger, and they seem to be more frequent because the larger distance means that there's a greater accounting of the birds being close to one another. So if I take the distance way down to 25, there's a lesser accounting that the birds will even be close to one another, and you may not see as many instances of the visualization. It's just little pieces, you see. They don't really clump together as well, although it is just a scale version of the larger cells. It's slightly different in how they'll line up. Still a neat effect. So that was one of the examples that I wanted to show you, and there's another one too. Let me grab that real fast here. You guys are going to see some weird stuff happening. But I'm going to go to the P5.js website. I'm going to go to the examples page, and I'm going to go all the way down to math, and in that it's going to have something called noise wave. And what it's noise is Perlin noise. I'm just going to copy that code and go back here to my other window. Let's paste that inside and take a look at what it is. This is a noise wave, a Perlin noise wave. And Perlin noise is a set of algorithms given to a guy whose last name happened to be Perlin. And it creates 3D landscapes. It creates these organic randomness. You don't really need to know that much about it. But what we're going to do with this visualization is use this to create a 3D landscape. when I first learned this saw this example, I was just learning P5.js, and I tried my best to pick this apart and do what I'm about to do now, and it was such a failure. So hopefully this will show you all the little things that you can do that it took me a minute to figure out. So the first thing I want to do is I don't want this to be a closed shape. So it still looks the same. Not much done there. That's because they add these lines to make it a box, make it look like this is like water in a tank. So let's take out this line. Let's take out this line. There we go. That's more, but why is it gloppy like that? Well, it's because it's the fill. So we don't want it to be filled in. So this statement here, that's got to be a no fill. And since we're no filling it, we have to make it a stroke, or it's going to disappear. So we can do that up in the setup, save us some processing speed. And we're going to do a stroke of white, and we're going to do 1 for our stroke weight. And down here, let's do high contrast. You know how I'm about the high contrast. Now let's see what this does. Okay, we have our single line now. We've taken that shape and we've made it into a single line, which is what we want to do. Now we want to take that line, and each time it runs from one edge of the screen to the next. So first I'll tell you what's happening. There's a loop, and it's running from this end to that end. And as it moves, each increment, it's finding a y value that's related to the y value before. And that's going to create this wave. So the x value is uniform increments, and then the y value changes based on this thing called Perlin noise. So each time it goes from this side of the screen to the other, it creates a segment of that Perlin noise. And then the next time around it goes to the next segment, and it keeps doing that. So if we start at the top of the screen and print one line wave, and then go down one increment, print another line wave, they should overlap in a neat way that creates this kind of landscapes. But how do we do that? Well, let's look at the wave itself, and that happens in this y variable, because this movement up and down is on the y-axis. We know it happens along this y variable, and they're mapping the value that returns from this noise function to a distance of 200 to 300, which is from here to there. So 200 is the y position relative to the 0 up here, 200 down here, 300 right here. So if I want the line to be up here, I need this 200 to be 0. But I want it to move, so I actually want it to be a variable. So I'm going to change it to I. And I is going to be a variable that moves from the top of the screen to the bottom. And the wave height or thickness is the distance that was between this 200 and 300. So it's actually 100. So the size of that wave is 100 units. Let's add it. So I'm going to add 100 units, possibly, it's in a range of 100, to this location I as it moves down the screen. So I isn't a variable yet, but it will be. And how do I make I a variable? Where do I need to do that at? I've completely forgotten what I was doing. Is that a loop? Yes, it is a loop. I'm going to make a for next loop, and it has to start at the beginning of that shape. Right? Okay, so let's do for I equals this. We have, forever, right? So I want it to go to the bottom of the screen plus its possible wave height, which is 100. And I want that increment to go 1 unit each cycle. And I want to start this cycle, or I want to start this loop at the beginning of the shape, and I want to close it at the end of the shape. All right. So let's see what happens. Let's just run this and see if anything breaks. So it's creating the 3D landscape here, but you can see it's it's just undulating, and it just looks like random snapshots of landscape. But there's a way that you can make each snapshot relational to the one before it and offset it just a little bit so that it looks like the landscape is moving up or down. So how do we do that? Well, right now, each time it goes to the bottom of the screen, or actually each time the shape is made, or as it's making the shape, it's adjusting this Y offset. And when it goes back up to the top of the screen, that Y offset compared to the last time it was at the top of the screen is really great. But we want that offset to be really small so that so the difference is more noticeable, so it's not so jumpy around here. So how do we do that? Well, the first thing I'm going to do is stop this program because it's really slow. And I want to change the canvas size so that this program runs a little bit faster. So I want it to be narrow and kind of long so we can see a lot of the landscape. So let's see it now. You can see it's just bubbling around. It kind of looks like it's relational. Each frame is relational, but it's too jittery. And that jittery is because of that gap. So I want to take the gap out. So when it goes back up here to draw and starts draw all over again, it's going back up to the top of the screen and it's going to draw that wave line down many times. I want to change that Y offset to 0 and see what happens. So instead of it just continuing with the Y offset and that huge gap difference between the last time it started at the top, now it's going to go back to 0. So each time it goes back to 0, it resets that noise function. So we're always getting the same set of noise values. So when it gets down here at the bottom and it starts back up here, instead of starting at 0, how about it starts off just a little bit different? So the second line gets printed up here and the top line disappears. And then every line moves up one. Let's see if we can do that. One of the ways that we can do that is we need an offset for our offset. So I'm going to make a variable here called ySet, and it's going to add a small increment to Y off each time it goes back up to the top of the screen to print the lines going down. And since that's a new variable, let's declare it up here. And it can be 0 up here, it doesn't matter. Now let's see what happens. Nothing again, because I need to pass that variable to here. Now something should happen. Each time it goes to the top, it's getting a little bit of a different starting position. And the net effect of that is the scrolling landscape. So we really didn't do a whole lot of changes to this program, and you were able to create this landscape. Now if I change that plus to a minus, what do you think is going to happen? It's just going to, the offset's going to go the other way, so instead of, we get to see lines that we didn't see before, and now it's going down the page. So that's two examples changed a little bit to create something really neat. I hope you've enjoyed this video. If you have, be sure to give me a like and a thumbs up and hit the notification if you want to see more videos like this, even though it is kind of rare for me to make these videos. Hopefully I'll be doing these more and some of my news videos less. But if you still follow me because of the art, here is one for you. And until next time, you guys, take care.